Alright, welcome back, guys. Today we're going to talk about matrix applications. In particular, we're going to talk about simultaneous equations. So, some of you guys hopefully will have seen this in high school, but I don't really want to assume that you've seen anything. So, what exactly do we mean by simultaneous equations? Well, simultaneous equations basically means two equations that you solve at the same time. So, because you have two equations, you can actually have two unknowns, so two pronumerals. So let's just write down one example of this and then see how we'd go about solving them using matrices. So if I have the set of equations 5 times x minus y is equal to 5, and then another equation, negative 13x plus 3y is equal to negative 11. Now what I'm going to try to convince you of is that, so this is a set of simultaneous equations, right? So I have two equations and two unknowns. What I'm going to try to convince you of is that this is the same thing as a matrix equation. In particular, the matrix equation where I multiply the matrix A, which is a known matrix, or a constant matrix, times the unknown matrix X, and get another known matrix, B. Okay, now like I say, I'm going to try to convince you of this. So basically what I'm going to do is show you how it works, okay? So I reckon I can write these two equations as this particular matrix equation. So I reckon I can write it as the matrix equation 5, negative 1, negative 13, and 3 times the unknown matrix x, y, and that this is equal to 5, negative 11. Alright, so in order to show you this, what we actually need to do is do this matrix multiplication here. So multiply this known matrix by this unknown matrix. So let's do that. 5 times x plus negative 1 times y is minus y. Negative 13 times x is negative 13x, plus 3 times y is 3y. So what this equation here is saying when we multiply these is that that matrix is equal to the matrix 5, negative 11. So now if you remember back to last term when we introduced matrices, we said that when two matrices are equal to each other, what that means is that all the elements have to be equal to each other. The elements in the same places rather have to be equal to each other. So this 5x minus y has to be equal to 5. And negative 13x plus 3y has to be equal to negative 11. So what I did was I multiplied this out and found that in order for this equation to be true, we had to have these equations, right, which are our original equations that we started with. So hopefully that's enough to convince you that when I have a set of simultaneous equations like this, I can actually write them as a matrix equation like this one here. So this matrix here, out the front, this unknown matrix, actually has a special name. It's called the coefficient matrix. It's the coefficient matrix. And what I did to find this was I just wrote out these simultaneous equations with the x's on the left-hand side, the y's on the right-hand side. So x is over here, y is over here, and then basically just took away the x's and put brackets around it. So the 5 goes to 5 here. Negative y is the same one as minus 1 times y, so that coefficient is negative 1. Negative 1 goes there. Negative 13 goes there. 3 goes there. And that's how you set up what your coefficient matrix is. Okay, so now that we've shown you how to set this up, let's go ahead and try to solve this set of simultaneous equations by solving the matrix equation. So there's nothing actually new, right? We did this last week. So we have this matrix equation A times x is equal to b, and we've already done this, right? I can solve this so I can find what x is by multiplying on the left-hand side by the inverse of a. So multiply the inverse of a times ax, and multiply this side as well by the same thing, a inverse times b. A inverse times a is the identity, right? That's what makes it the inverse. And the right-hand side is still just the inverse of a times b. Now the identity times x just equals x, which is what makes it the identity. So x is equal to the inverse of a times b. So that's our solution. So what I need to do to actually work out what the solution to that set of simultaneous equations is to find the inverse of a and multiply it by b. So here when I set this out, remember this is the equation that I was using. So this here is a, this matrix is x, and this matrix is b. So I need to find the inverse of this matrix here, and then multiply it by this matrix here in order to find our unknown matrix xy. So let's just focus on finding the inverse of a first of all. So I had a is equal to 5, negative 1, negative 13, 3. And what I want to find, first of all, is to find the inverse of a. So again, this is just applying the formula that we learned last week. So the inverse of a, if we know a, is 1 divided by the determinant. So 1 times 1 divided by 5 times 3 is 15, minus negative 1 times negative 13 is 13. So negative times a negative is a positive. So that's 15 minus 13. And this matrix, we switch these two numbers around, remember? So 3 and 5, and negative 1 becomes positive 1. Negative 13 becomes positive 13. And there we are. We found our inverse matrix. All we need to do is simplify it. 15 minus 13 is 2. So this whole thing is just 1/2 times the matrix 3, 1, 13, 5. So now what I want to do is, in order to check this, right, you could check it a number of ways, but what I want to do is show you how to use a tool that we suggested you use on your assignment. So what I'm going to do is open up this tool that I linked to in the assignment, so this is it right here, and I'm going to put in this matrix A. So in order to do this, all I do is type in, what was it again? 5, negative 1, negative 13, 3. 5, space, negative 1, and then enter to go to a new line, negative 13, and 3. So that's our matrix, right? Now you'll see a bunch of different things that you can tick down here, right? So a bunch of these you don't know what they are, and that's fine. You do know what the inverse of a matrix is, and that's what we're trying to find. So tick that box, and then tick calculate. And it tells us that the inverse of that matrix here is this here, 1.5, 1/2, 6.5, and 2.5. 1.5, right? 3 divided by 2 is 1.5. 1 divided by 2 is 1/2. 13 divided by 2 is 6.5. 5 divided by 2 is 2.5. So it looks like we've got the right answer for the inverse of a. Okay, so remember now we said that x is equal to the inverse of a times b. We just found what the inverse of a is. It's 1/2 times 3, 1, 13, 5. And b was the matrix 5, negative 11. Okay, so our unknown matrix X is just going to be these two matrices multiplied by each other. So I'm going to keep this 1/2 at the front for now and multiply these two. So 3 times 5 is 15, plus 1 times negative 11 is minus 11. 13 times 5 is 65, plus 5 times negative 11 is negative 55, so minus 55. So simplifying this, we get 1/2 times 15 minus 11 is 4. 65 minus 55 is 10. And simplifying even further, 4 divided by 2 is 2. And 10 divided by 2 is 5. So that's our unknown matrix X. And what that actually means, if you remember in terms of the simultaneous equation that we started with, is that this thing here is equal to xy, which means x is equal to 2 and y is equal to 5. So you could actually take these numbers and plug them back into the original simultaneous equations up here and check that they're correct. But what I'm actually going to do is, instead of doing that, again, try to show you how to use this matrix calculator by multiplying the inverse of A here times B, just to show you how to do matrix multiplication with that calculator. So if I go back to this calculator, so I want to keep this matrix here. So what I'm actually going to do is copy it. This is the inverse of A, and I want to calculate the inverse of A times the matrix B. So I'm going to copy this, copy, and then I'm going to go back to the online matrix calculator, and then I'm going to go to this button here, matrix multiplication. So here it gives me space to enter two matrices. So for matrix A, the one on the left-hand side, I'm going to paste that matrix that I just had. And for matrix here, I'm going to enter B from here. So 5, negative 11, 5, negative 11. And then I'm going to multiply A times B, so tick that box. And there we are. It says that the product of A times B is the matrix 2, 5. 2, 5, exactly as we found. So that's how you might like to check, or how you might like to use the calculator to do questions on the assignment. Okay, so now, because that took us a little while, I think it might be a good idea just to do one more, just to remind you of how this actually all works. So let's do one more example really quickly of how to use matrices to solve a simultaneous equation. So let's say I have simultaneous equations 2x minus 3y is equal to 5, and x minus y is equal to 3. So remember, I can write this as a matrix equation by writing down the coefficient matrix here, 2, negative 3, 1, negative 1, times the matrix xy, and setting this equal to this matrix over here, 5, 3. Okay, and I can find, so remember, this is the same thing as writing it out as A, x is equal to b. So just like I solved this before, right, x is still going to be the inverse of A times b. It's just now that the matrix A has changed and the matrix B has changed. So we need to find now the inverse of this new matrix A. So we have A is equal to 2, negative 3, 1, negative 1. And what I want to do is work out what the inverse of this is. So the inverse of the matrix A is 1 divided by the determinant of A, so that's 2 times negative 1 is negative 2, minus negative 3 times 1 is negative 3, so minus negative 3 is positive 3, times the matrix where I switch these two around, so that's negative 1, 2, negative 3 becomes 3, and 1 becomes negative 1. Okay, so let's simplify this out now. 1 divided by negative 2 plus 3 is plus 1, so that's 1 over 1 times negative 1, 3, negative 1, 2. 1 divided by 1 is 1, so this whole thing simplified as just negative 1, 3, negative 1, 2. And now remember we said that x, our unknown, which we wanted to solve for, is equal to the inverse of a times b. We just found the inverse of a is negative 1, 3, negative 1, 2. And b was the matrix 5, 3. So now, to finish this off, all we need to do is multiply these two matrices together. So negative 1 times 5 is negative 5, plus 3 times 3 is 9. Negative 1 times 5 is negative 5, plus 2 times 3 is 6. And we can simplify this as negative 5 plus 9 is 4. Negative 5 plus 6 is 1. And there we have it. That's our solution for the matrix X was 4, 1. Or another way of saying this, right, is that this is X, Y, and therefore X is equal to 4, and Y is equal to 1. So now, as another way of checking that this is actually right, what I'd like you to do is to take these numbers and plug back into this equation up here, and double check that it actually gives you the right thing. But I think I'll try to just finish there and leave you guys to do that on your own. Alright, thanks guys.